Hello and welcome back to AP Pre-Calculus. Today's lesson is 3.2, Sine, Cosine, and Tangent, Part 1. So here in AP Pre-Calculus, we're going to approach angles in a way that may be different than we've done in the past. We're going to approach them in a generalized method that allows us to view them through a periodic lens, meaning things are going to happen over and over again the same way. To do this, we must make some definitions clear first. Definition 1, standard position. In the coordinate plane, that's your xy axis, an angle is in the standard position when its vertex is at the origin. So here's our vertex right there at the origin, and one of the rays of the angles lies on the positive x-axis. So we have to have the vertex here, and one ray has to go this direction. All right, that is important. The terminal ray is the other angle, the other ray that makes up the angle, I should say. And that could end up anywhere. And if you remember our quadrants, we got 1, 2, 3, and 4. Okay? I'm hoping that you remember sine, cosine, and tangent from back in maybe Algebra 1, but definitely some in geometry. You probably learned SOHCAHTOA. Sine is opposite over hypotenuse. That's when we were dealing with actual triangles. Well, we're here in the coordinate plane, and we're talking about angles. We're not really talking about triangles in the complete sense, but it actually does end up making a nice right triangle. It's just we don't have that third leg of the triangle. It's just kind of imaginary, if you will. So if we have a circle that's centered at the origin, and then we have an angle in standard position, then those angles, those rays, will intersect that circle at some point, right? Because the rays go on forever, and if you go on forever, you have to go through the circle. Look at my circle here. We have an angle in standard position because the vertex is at the origin, and I have one of my rays going down the x-axis, and then I have the other one. It's in the first quadrant here, but I intersected the circle, and we only care about this in the circle. If you notice, I made a right triangle by dropping down that dotted line right here. And by making the dotted line this way, I actually made a big rectangle, but I don't really care about the rectangle. I want you to notice that wouldn't this side be y and this side be x? So that's what I want to think about. I want to think about that bottom line being x, not that dotted line at the top. So I'm going to erase that one and put it down at the bottom. So let's kind of forget about this guy up here. So we'll just cross him out. All right. So now I have a right triangle, which means my SOHCAHTOA works. If you look over here, it says sine equals y over r. But if I wanted to, couldn't I just label my sides as opposite, adjacent, and hypotenuse? And then I could go back to geometry world. But guys, we're way above geometry now. I mean, we are in a college level class. So we got to get away from doing things the old kind of, lower level way. So it should make sense that the up and down value, it's always the opposite because my angle is always in the center, and the vertical side to my triangle will always be y value because it's vertical. It's going up and down. And then my adjacent is always going to go left or right, so that is my x value. So sine is y over r, opposite over hypotenuse if you need to. And then same thing with cosine. It's x over r. Okay? And then last is tangent is y over x, or sine over cosine. Because if I wanted to, I could do sine is y over r, cosine is x over r, and that will simplify down to y over x. Now, let me give you a way to maybe remember this. Sine and cosine. We do ordered pairs, right? These are ordered pairs here, right? And one of the nice things about ordered pair is they're usually alphabetical order. So think about x and y. What comes first? Well, x comes before y. Well, cosine and sine. Cosine starts with C, sine starts with S, cosine comes first. So cosine goes with x, sine goes with y. That's one of the ways I've used to remember it through my years of math. Example 1. The figure shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. The coordinates are x, y. Which of the following is true about cosine? Before we answer this question, let's go ahead and talk about this hypotenuse, right? What's another name for that hypotenuse? If you didn't think about it being a right triangle, you just thought about it going from the center to the edge of a circle, what do we call that? Well, the radius, right? And how big is my radius in this circle? Do we know? I know that this point is x, y. They didn't give me anything more than that. But they did give me this point right here. So isn't this also a radius? So if that's 3, then this guy has to be 3. Can I fill in the other sides of my triangle? Well, not with numbers, but I do know that this is the y value and this is the x value. So now I might be able to answer these questions. I notice that all 4 of my choices here are starting with cosine. And if you remember what I just said, cosine goes with x. So I can get rid of B and C right now because they put cosine with y. We would never do that, all right? And cosine is adjacent over hypotenuse. And I know the hypotenuse is 3, so hypotenuse has to be my denominator, so the answer has to be A. All right, let's try example 2. The figure shows a circle with a radius of 5 centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. I want to find the following values. Well, they didn't really give me the coordinates for P, but they did give me this vertical line, and P would be a reflection over the x-axis. So how could I get to point P? How far did I go over? Well, I went over 3. How far did I go down? Went down 4. How would you so down 4? That'd be 3, negative 4. And I know that this is 5. So if you want to, you can put a negative there. Some people don't like to put a negative there because you can't have a negative side, but we're not really talking about a triangle here. It's a dotted line. So we can have negatives on dotted lines. Okay, so let's do sine. Sine goes with the y value, the opposite. What's opposite our theta? Negative 4 over 5. Cosine goes with the x value, 3 over 5. And tangent is y over x. What's the y value? Negative 4. What's the x value? 3. And that's all you have to do. Example 3. So they're giving this big old coordinate plane with a circle, center at the origin, and a lot of stuff is going on here. And it looks a lot more complicated than it is. So what we're wanting to do is we're wanting to find all of these points, Q, R, and S. And they're just reflections across axes, right? So to get from P to Q, what would I have to do? Well, I'm going up the same amount, so the y value stays the same, but the x went to the left, so that's negative x. What about P to S? This time my x stayed the same, but the y became negative. So last quadrant is quadrant 3. So this time I'm going to go this way. I went negative x, but I also went down. So that's how we would write those. And what about my radius? Well, right here, because of this point right here, they're saying the radius is r. So each one of these guys is r. Okay? So for my coordinates down here, you could put these, I guess I put them up there, but you could just transfer them down there to point Q, point R, point S. So like that. And then let's do example 4. Find the sine of an angle whose terminal ray intersects the circle at point. So sine at S. So we're talking about this triangle right here, right? And sine goes with y. So the y value for there is negative y, and the radius is r. What about 5? Find the cosine whose terminal ray intersects the circle at Q. So now we're talking about this triangle. Cosine goes with x, so it's negative x over r. And then last but not least, the tangent that intersects with r. It's this guy right here. And my tangent is y over x. So I get negative y over negative x, and we would not leave it like that. We would say y over x. Last one. Example 7. Let theta be an angle in standard position whose terminal ray coincides with the line y equals negative 3x in quadrant 2. All right, so I got my coordinate plane there. That blue line is the line y equals negative 3x, and we want a terminal ray that coincides with that line. So here's my standard angle, right? Here's my terminal side. So I want it to go right here where it coincides, right? And then we want to kind of make our dotted line, right, like this. So there's my theta right in there. Okay, so now I need to fill in what I know. So what exactly is this right here, this negative 3 in front of the x? Well, isn't that the slope? That tells us how many we go over and up. Well, to make, we have to have a negative 3 over 1 somehow. Well, I went up 3, so that would be positive, and I get negative 1. We could have used any kind of ratio that would make negative 3. Like I could have had my vertical be 6 and my horizontal be negative 2, 9 and negative 3. It doesn't really matter for this problem. So we have our x and our y, but I still need a radius. How are we going to get our radius? Old Pythag, right? Can't forget about this guy. And we're looking for that c. So I go 3 squared plus 1 squared equals c squared, and I end up getting c equals the square root of 10. Now I don't have to put plus or minus on this one because we are talking about a distance. Can't have a radius with a negative value. That doesn't make sense. And now we can answer all of these little ratio questions. Sine theta, remember, is opposite over hypotenuse, but sine goes with y. So we could say 3 over the square root of 10. And unfortunately, we're not in calculus yet, so it's probably a good idea to simplify this. So we would multiply top and bottom by square root of 10, and we get 3 square roots of 10 over 10. What about cosine? Well, it's adjacent over hypotenuse, or it's the x value over the radius, right? So we got negative 1 over square root of 10. And we do the same thing, and we get negative square root of 10 over 10. And last but not least, tangent is opposite over adjacent, or y over x, and we get 3 over negative 1, or negative 3.